Hello everyone, welcome back to my channel. My name is Sanjeev Garg. Today we are going to discuss about the next dynamic programming problem, that is climbing stair. This problem is just similar to the previous one, that is the Fibonacci series. So if you have not watched my previous video, I would highly recommend you to watch my previous video so that you can easily understand this problem. Okay, so let's get started with this problem. Okay, so climbing stairs. So let's first read the problem. You are climbing a stair. It takes n step to reach the top. Each time you can either climb one step or two step. In how many distinct ways you can climb to the top? Okay, so let's try to understand the problem. At each step you can take either one step or two step. So how can you take this step? Let's understand this with the example. Let's say, okay, so let's say we have this steps: step 1, step 2, step 3, step 4, step 5, or step 0. Okay, this is our step 0. This is step 1. Let's say step 1, this is step 2, this is step 3, this is step 4, this is step 5. Okay, so either you can go from the down to bottom approach or from top to down approach. This is bottom to top, this is top to down approach. Okay, let's go with the top to down approach. Okay, so you have to reach at this step 5. Okay, so how you will reach to this step 5? Okay, let's say you have to reach here. Okay, how many ways? So this function step 5, what this function will signifies? This function says that how many ways to reach at the step 5. This s4 says that, similarly this s4 says that how many ways to reach at s4. So let's start with s5. So how I will reach to the s5 step 5? How I will reach? Either I will reach from the step 4, or either I will reach from the step 3. Okay, so what I will give, I will say to the step 4 and the step 3, hey step 4, please give me total number of ways to reach at step 4. And I also will say to the step 3 that, hey, how many ways to reach at step 3. So let's say step 3 has 2 ways, step 4 has 2 ways, so total is, it will be 4 ways at step 5. This is an example I am taking. This is not exactly the question, but I am taking an example to make you better understand what exactly the s5 means. Okay, similarly for the s4. Okay, I will ask to step 3 and ask to step 2, how many ways to reach at step 3, how many ways to reach at step 4. The sum of total ways to reach at step 2 plus the sum of total ways to reach at step 3. So step 4 will be simply sum of total number of ways to reach at step 3 plus sum of total number of ways to reach at step 2. Okay, I will ask to my previous two steps. Okay, now let's say for the step 2, I will ask to step 1, hey, how many ways to reach at you? And I will also ask to step 0, hey, how many ways to reach at you or at step 0. Okay, so at step 2, I'm asking to step 1 and I'm asking to step 0. Okay, so now try to understand this. S5 means how many ways to reach at step 5. S4 means how many ways to reach at step 4. Step 5 will ask step 4 and step 3, and will add up these two values. This is the result for the step 5. Similarly for the step 4, it will ask to step 3 and it will ask to step 2, and result will be the sum of these two values. Okay, if I'll show this you within a hierarchy example. Okay, so let's say I am at step 5. So S5 means how many ways to reach at step 5. Step 5 will ask to step 4, hey, how many ways to reach at you? And will ask to step 3, hey, how many ways to reach at you? Similarly, step 4 will ask step 3 and step 2. Similarly, step 3 will ask to step 2 and step 1. Similarly, step 3 will ask to step 2 and this one step 1, and this step 1 and step 0. Okay, similarly this step 1 and this step 0. Okay, and if you see, this is a step 0, this is step 1, this is step 2, this is step 3, this is step 0, this is step 1, this is step 2. If this is the only step, let's say if we have only one step, this is step 0, I'm at 0. Okay, I'm at 0. To reach at 0 from 0, how many ways? There is only one way, there is only one way, just jump from here to here only. Let's say now if my s of 0 is will be 0 only. Now let's say I am at step 1. How I will reach to step 1? I will ask to the step 0, how many ways to reach 0? He will say 1, so step 1 will be only one way. Step 1 will be only one way. Just there is one way to jump from 0 to 1 or 1 to 0. You can go from the top down or bottom approach. Okay, okay, this is the way. So we can take it as a our base condition. We already know the answer for step 0 and the step 1. Okay, so now let's start. Now let's see this one. Okay, so this is the step 5. If you see, we have to calculate one function only there. Now step 4, step 3, we have to calculate two function here, 1 3, step 3, step 2, step 1, we have to calculate 4 function here basically. Similarly, in the worst case, we have to calculate 8 function here. So to 1 we can write simply 2 raised to power 0. We can write here 2 raised to power 1. We can write 2 raised to power 2 here, and we can write 2 raised to power 3 here, and so on. So if I write in a single line 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 up to 2 raised to power n for the n steps. So it will combine as in a GP series. So it will be 2 raised to power n only. So here the time complexity will be order of 2 raised to power n only. To order of 2 raised to power n only. One more thing, if you see, we are calculating step 2 here, we are calculating step 2 here, we are calculating step 1 here, step 1 here also, step 1 here also. Once at calculation at one step we are doing many times, not only one time, many times. This is the reason. Okay, this is the reason also. Okay, so this is the time complexity. As I already told you, let's talk about the space complexity as well. Okay, at each step what we are doing to calculate the step 5, we are putting into the stack. After that, what we are doing to calculate the step 5, we have to calculate step 4, we have to calculate step 3. Okay, to calculate the step 4, we need to calculate step 3, then step 2, then step 1. Okay, once the step 1 is calculated, so step to calculate the step 2, we need step 1 and the step 0. 1 is calculated, now we will put step 0 into the stack. Step 0 is calculated, means step 2 is calculated. Now step 2 is calculated. To calculate the step 3, 2 is calculated. Now we have to calculate step 1. To calculate step 1, we again will put step 0 into the stack. Okay, if all these calculated, step 4 is calculated, step 3 is calculated. To calculate this step 4, we need to calculate step 3 and step 2. Step 3 is already calculated here. Now we will put step 2 here. So if you see, we are putting all these value again and again in this stack to calculate each and every step. So it will only, if I'll talk about the stack space here is no is just same as the total number of functions that you have to calculate, that is order of 2 raised to power n only. Okay, So this is the space complexity. Space complexity here is order of 2 raised to power n only. Okay, now as I already told you, if you see, we are calculating these functions again and again, so we can say these are overlapping sub problems. So how we can we, is there any way if we can store this value? Yes, there is a way. What we will do, once at the first time when we will calculate a value, we will store into the an array. Let's take the example. Let's take example till step 4. Okay, so we have the step 0, this one, this is step 1, this is step 2, this is step 3. Okay, this is step 4. Now to calculate this step 4 will ask to the step 3, hey, how many ways to come to you, and it will ask to the step 2 as well. Okay, so how the stack will go here, first we will put stack 4 into the stack, first after that we will put step 3 into the stack, this one. To calculate the 3 we need step 2. Okay, now we will put step 2 into the stack, after that we will put step 1 into the stack, step 1 into the stack. Okay, and after that we will put step 0 into the stack, step 0 into the stack, step 0 into the stack. Okay, we know that answer of this step 0 is 1, so this will remove from the stack, and after removing this, before removing from the stack, we will put its result into the array as well, now this is calculated. To calculate this step 1 we need step 0. Yes, step 0. Before putting into the stack, we will check whether if this value is present in the array or not. If you see, stack 0 is already present 1 here, so we don't need to calculate it again and again. So now 1 is calculated, 1 we will put here. Now step 2, now we have to calculate at step 2. Step 2, as 1 is already calculated, now again we should go to the step 1, but before going to that, we already know that step 1 is already calculated, so 1 will come from here, so it will come 2. 1 plus 1, that is 2 only. 1 come from where? 1 come from here, 2 only. So if you see, this will fill in one time only. We are not repeating, or we are not putting this value again into this stack. Okay, so and in this we are calculating each functions only once. So if you see, okay, this f6 step 0, step 1, step 2, step 3, okay, step 4, we are not calculating this one, because we have already calculated these values. So here the time complexity is the total number of the function that we are calling. Okay, so time complexity will be order of n only. We are calculating these functions only. Okay, so if I'll talk about the space complexity will be total number of the functions that we are putting into the stack. These functions are the same as we are calculated in the time complexity, that is order of n only. Okay, this is the stack space, that we are taking. Okay, this approach that I discussed is from the top to the bottom approach, and this is the stack space. Also, as I said, we are taking this array, so this array also will take order of n time. So array size is order of n only. So total space complexity will be order of n plus order of n only. So this will be 2 order of n only, so it will be order of n only. Okay, so this approach, we will say this approach to the memoization. Why this is called memoization? Because we are memorizing these values into an array. Okay, so if you see in the space complexity, order of n and order of n, can we remove this stack space? Okay, from the problem we can simply see that let's say if I am 0 step, 1 step, 2 step, 3 step, 4 step. Okay, this is the step 4. Step 4 will ask to the step 3 and step 2. Hey, how many ways to reach at step 2 and how many ways to reach at step 3, and we will add up these two values and sum will be our answer. Okay, so at each step we need sum of its previous two values only. So why not to store these values from the start and go in the iterative way? In this way there is no need of the recursion. So how we will do this? Let's do this. This is the step 0, this is step 1, this is step 2, this is step 3, this is step 0, this is step 1, this is step 2, and this is step 3. Okay, so at step 0 we have only one answer. We already know that at step 0, if I am at step 0, how many ways to reach from 0 to the 0? There is only one way, just jump from 0 to the 0. If I am at step 1, let's say I am at 1, how many ways to reach at 1? I will ask to the 0, hey, how many ways to reach at u? He will say 1. Then some answer will be the sum, add up with this value. So 1 will come here. Now let's say if I am at this one, 2. At step 2 I will ask to the step 1 and step 0, hey, how many ways to reach at step 1 and step 0? And answer will be the add up of these two values. Okay, so what I am doing here, I am just adding the previous two values only. So there is no need to go recursion wise. We are going iteratively here. Just a simple for loop we are using here. Okay, so if you see, I am storing these value in an array, step 0, at step 1, at step 2, and step 3, and step 4. Okay, so here the time complexity will remain same, because at each step we have to calculate. Step 4 we have to calculate, step 3 we have to calculate, similarly up to step 0 we will have to calculate. So time complexity will remain same, is order of n only, but the space complexity, as we are not using any stack, so just this array only, so it will be order of n only. We are not using stack space here. Now let's go with this one. Okay, if you see, we just need two variables instead of this storing this array. Just we need these two variables. Okay, at this is step 0, this is step 0, this is step 1, this is step 2, this is step 3, this is step 3. Okay, if I'm at the step 2, I will ask to step 1 and the step 2, hey, how many ways to reach at step 1? Hey, how many ways to reach at step 0? And answer will be for the step 2 will be the sum of these two, S0 and the S1. So let's say this is previous 1, this is previous 2, we will add these values. So let's say result is previous 1 plus previous 2. Okay, so answer will be here. So for step 3, sum of these step 2 and step 1. So now I just need to change my previous 1 will be previous 2 only, and previous 2 will be my result only, just nothing else, just two variables. So now there is no need to take this array, so we are just taking two variables. So time complexity will be order of 1 only, because there is result, previous 1, previous 2, these are the three variables, these are the constant. Order of 3 is similar to the order of 1 only. So but this is the space complexity, and time complexity will be, this is space complexity. Time complexity is remain same, order of n only, because we are calculating each functions at least one. Okay, so let's try to run the code now. I think you got better understanding of the problem, how we are going from the recursion to the tabulation to the memoization and to the space optimization by using the two variable. Let's do it the coding. Okay, let's do it with the coding. Okay, so the same thing we will do as we did in the previous question. We will make a util function. Okay, let's make a util function here. Okay, and from this we will simply return our this function, util function, and we will pass an error. Okay, first is, if I'm at step 0, there is one way to reach from 0 to 0, there is only one way. And if I am step 1, how many ways to reach at step 1 from the 0? There is only one way. So if my n is less than equal to 1, I will simply return there is only one way, there is only one way. Okay, else I need to calculate my, I need to run this recursion. I will ask, I will return return, I will ask to my previous, okay, I will ask to my previous, hey, how many ways to reach at you? And second step, I will ask to another previous, hey, how many ways to reach at you? And answer will be the sum of these two. Okay, so let's try to run simply return, run this. Let's see if it runs on. Yes, it runs. Let's try to submit this. Okay, okay, so if you see, we are able to submit this, but it's saying that time limit exceeded. Why? Because if you see, this is a recursion approach, so the time complexity is 2 raised to power n, this, that is exponential. So how can we reduce this time from the 2 raised to power n to the order of n? As I already told, this is the memoization. We will take in a dp array new int. As for step 3, we need step 2, step 1, step 0, step 3. So we are taking an extra for the n equal to 0. So we will take the size of the array will be n plus 1. Simply pass the dp here. Simply take int dp here as well. In the function we will pass dp. In this function as well we will pass dp. Okay, so before, okay, so this dp, what we will do in the start, let's say fill this dp array with -1 only. Okay, -1 only before. Okay, let's say if I want to calculate for the step 3, before calculating, let's check if this value is present in the dp or not. Let's say dp of n is not equal to -1, means value is present. I will simply return dp of n. Otherwise just need this, let's say remove this else to make it simple. In any case we will calculate the dp, we will calculate the let's say for, we are calculating for the step 3, we have to calculate for the step 3. Now after calculating for the next use, we have to store this in the, is this in our array. So let's say dp of n. Okay, after calculating we are storing, just we are storing so that we can use next time if the same step we need to calculate, we have to calculate. Let's try to run this now. Okay, let's try to submit this. Okay, that's great, we are able to submit this. Now if you see, we are going in the recursion way, we are taking this recursion. So here the time complexity is order of n for this recursion and order of n for this array. So let's remove this recursion. How can we remove this recursion? We are keeping this array same as it is, just we have to remove this one. Okay, so and first base case value we need to fill, base case value we need to fill dp of 0 is equal to 0, sorry, dp of 0 is equal to 1, dp of 1 equal to 1, and Now what we will do, for loop, we will use a for loop for int I equal to 2. From the 2, I is less than equal to and I plus plus. Okay, simply dp of I we are calculating, we have to ask to my previous two variables. Okay, I minus 2 or I minus 1 plus dp of I minus 2. At last we will simply return dp of n. Okay, now dp we need. Okay, let's try to run this. Yes, we are able to submit this as well or not. Let check. Yes, we are able to submit. So now we have reduced the stack space. If you see, let's say if my n is 0, n0 will come here and n0 will come here. If this is 0 is equal to 1, we will return 0 here. So if we can remove equal as well, we can write 0 as well here. For the 0 and the 1 we are already handling these cases. Let's try to run if we can do this or not. Yes, yes, we are able to submit this. Okay, so this is the way we have reduced our stack space. Now if you see this array, we are in this question what we are doing, we are depending on the two previous values. So instead of this array we can take the two values. Let's remove this array. Let's remove this array. Let's remove the dp from this as well. Let's remove the dp from this as well. Now okay, so instead of this let's take it int previous one, and this one is int previous 2. Okay, now also take one variable to store the result. Let's say initial value is 0. So here my result will be previous of 1 plus previous of 2. Okay, now just need to change previous of 1 to previous of 2, and my previous of 2 will be my result only. We'll need to return, and let's see the base case. If 0 will come, okay, so for 0 this will come dp of 0. So we are returning 0 result here. Okay, for the 0 it's returning less than equal to 0. We have to write for the 1 here. Okay, let's try to run this. Yes, we are able to run this. Let's try to submit this. Yes, now we can submit this. Now if you see, we are taking here previous one, previous two, and result, only 3 variables, order of 3, that is order of 1 only. Okay, I hope you got a better understanding of what exactly the dynamic programming we are going to use in our next questions as well. So this is the just start of the dynamic programming, how we reduced from the 2 raised power n time complexity to the order of n, and how we reduce space complexity from 2 raised power n to the order of 1. So this is the way how the dynamic programming helps to optimize our solution. So that's all for today video. I hope you like my video. Please subscribe, do like, do comment on my channel, so that I can see your comments and what exactly I have to improve, or I can make better video and good video for the next time. Thank you guys.